A little chilly in the shop this morning, about 42 degrees. So this little window in here is actually made out of mica, just like the old style wood stoves. And I can actually open this up. Ugh. So on these old style oil furnaces, you can actually tune the intensity of the flame, which is why this window is here. And so you can adjust the airflow with this carburetor here, and then adjust the height of the flame. So right here is the best seat in the house when the furnace is on, because I get a big blast of hot air coming down through that vent. So I can just stand here and warm up if I'm feeling cold. And you know, I don't enjoy working with the heat off. If I'm busy building things and moving parts around, and getting exercise, the cold temperatures really don't affect me, because I'll actually break a sweat sometimes at 50 degrees if I'm, doing something busy. But if I'm just standing still or just cleaning up or putzing around, it's hard to endure that temperature over time. So I do run the heat. I'm not a masochist when it comes to depriving myself of any form of comfort. And that heat really is nice. Alright, well, for those who found some value in the information of my last lecture video, I thought I would expand a little bit and talk about how the dust silo actually works as a separator. Because it's not only just a big containment to contain sawdust, it's also a very functional separator. And what that means is a separator is just something that takes dust out of the exhaust system or the intake system to keep dust from building up in the filters, so filters run more efficiently. So cyclones are a type of separator, and then there's a whole variety of other home-built separators that people make on YouTube, and I think some of those are really neat, but it seems like the direction of design in home shop-built separators are geared towards being really compact so that they fit inside the shop, or on top of a 5-gallon bucket, or on top of a shop vac, or combining with a 30-gallon waste barrel like one of these. These make very cheap and effective secondary containments for dust. You could build a lid that has the intake and exhaust port that function as a separating unit. And my silo is essentially the same thing, but it's scaled up to a much larger size. Part of designing an efficient system is using the right size of pipe in your system that correlates with the CFM output of your blower, and it also depends on the length of the piping in the shop. I've noticed that some people design dust collector systems with hanging pipe in their shop, and they seem to use an excessive length of pipe to connect to their machines and to connect to their separators, and you really have to keep in mind that you need to minimize the length of piping that you use in your system to connect all of your components, because your static pressure dissipates very rapidly the longer length of pipe that you hang in the shop. To give you some sort of reference point, in my old system, I tested it. I had a 1.5 horsepower jet, single stage bag filter type. And the longest length of 4-inch PVC pipe that I could run to really effectively use it on anything was 40 feet. So when I start running a length of pipe that goes beyond 30 feet, you really start to see a depreciation in the performance of the dust collector, in its ability to suck up dust, and that airflow really dissipates. And when it goes above 40 feet, it's really almost useless. So you know, I was limited to how long of a length of pipe I could hang with my old 1.5 horsepower blower. You know, but with my new system, I've connected 1, 2, 3, 4, 5 lengths of 6-inch PVC, which is 10 feet long. So I have, you know, 60, 70 feet here of length of pipe. And with the 3 horsepower blower, I can hook up a 4-inch reducer at any point, and it works very well. So I can get a much longer length of pipe with a more powerful blower and the 6-inch PVC pipe. I left Kitty in the garage. She sounds upset. It was very cold last night. So, separating efficiency for a dust collection system, whether it's a cyclone or a homemade dust separator, you know, the goal of the separator is to take as much dust as possible out of the exhaust system so that it doesn't contact the filter. And the more dust you can keep out of your filter, the longer the filter is going to work and run, and the more efficiency you're going to have with your system. It's going to perform better, and it's going to require less maintenance. So ideally, if you have a perfect separator, you don't even need to filter. If your separator is 100% efficient, you don't need to have any filtering at all. Just the exhaust would be clean air. But that's impossible because the particulate size that's generated with a lot of machine cutting operations with wood, it generates a lot of fine dust that's very difficult to separate out because it's you know, some of it's as fine as smoke particles that can remain buoyant in air for an extended period of time, and any airflow that you have will carry those particles great distances. So you know, that's the problem dust that you have. That fine dust that permeates all the space inside the shop is the dust that's the least healthy for you, the most hazardous, and the biggest problem that you have to deal with. You don't want that stuff in your shop at any point. So really fine dust that permeates the shop has potential to create very serious hazards. When it builds up into a thicker layer and you have higher humidity weather conditions, that layer of fine dust can actually conduct a charge, so you can actually get the risk of sparks occurring in areas where you have fine particulates built up into a conductive layer. You can have electrical problems because that really fine dust, which is essentially like smoke, can actually permeate these spaces inside of electrical boxes, inside of your outlets, and then it can gradually build up a little fine layer inside of there, and then in higher humidity conditions you can get a short circuit. And if you have any grounding problems in your electrical system, then you have the fire risk associated with ground faults and sparks. So you know, that's why malfunctioning dust filters or malfunctioning systems can create such a hazard. Isn't that right, Kitty? You're a dust hazard. You're more maintenance than my system. You know that. Oh, look at you. You're all dusty now. See? This is what happens. Now you're going to track that all over the place. Okay, so my dust silo has two components to the effectiveness of its dust separation capability. And the first component of that is the same as any other cyclone or other type of separator, in that it creates an inertia effect with the circular vortex, and that inertia pushes the sawdust to the perimeter of the containment. And in a cyclone, that kind of directs it into another containment, which collects most of the dust. So my dust silo does essentially the same thing that a cyclone does, is that it creates that rotating wall of dust, but it doesn't have that conical vortex type shape to it. It's just a straight up down cylinder. And that's actually a unique aspect to my system, because what's happening is that there's just one big giant rotating column of air inside of that silo. And that creates a very large center portion where there isn't any airflow at all, or very little airflow. So there's a very large vertical travel from wherever the bottom of the dust pile is to the top of the silo. And that very large vertical travel is what contributes to its dust separation capabilities for separating out really fine particles. Because only the very finest particles can make it up all the way to the top of the silo. And everything else is affected by gravity enough that it settles in to the bottom eventually, and it doesn't make it all the way to the top. So I could also call my silo containment system a gravity well separator, because essentially it's the force of gravity that's enacting on both the coarse and the fine particles, in conjunction with the inertia of the rotating wall column of air, that contribute to very efficient dust separation. A mathematical or physical concept or relationship that's very important for designing a dust collection system is the relationship between the surface area of the pipe that you're directing your airflow through and the velocity of the air itself. And the relationship is simple. The surface area of the size of the pipe or containment that you're using is directly proportional to the velocity of air that is going to flow through that pipe or containment. So the velocity of the air of that updraft inside the silo that's in the center of that rotating column of air, the velocity of that updraft is what gives gravity time to work on those particles. So the longer the time the dust is suspended inside of that silo, the more effect gravity has to push those particles down to the bottom and settle in. So if I had a 6-foot diameter silo, I would have 3 or 4 times the surface area of the pipe, and I would have 3 or 4 times less velocity, and I could even get finer particles to settle down. So the size of the containment has a direct relationship between the velocity of airflow through that containment and the ability to contain smaller and smaller particles. So it seems a little bit wordy, but essentially bigger is better. 7-inch inlet blowing my on my blower, and that's blowing into a 36-inch containment. I'm going from a 7-inch to a 36-inch pipe, essentially. And so if my velocity is known for my blower, I think it's rated at, I can't remember off the top of my head, but it's like 2300, 2400 CFM with the 3 horsepower blower, a single stage blower like that. I'll have to go and verify that. But your CFM rating for your dust collection system is going to be known, and that's your optimum CFM when it's not connected to any length of pipe. Okay, so you can use that as an estimate, and then you can use that to extrapolate what your airflow, what your CFM velocity airflow would be inside a 36-inch pipe, which is what I have in my silo outside. So going from 7-inch to 36-inch is a dramatic decrease, in the velocity. And that's a big contributing factor in how much fine particulate can settle inside a 36-inch diameter pipe or similar size containment. It could be a square pipe. In my system I have some space between the intake of the blower and the top of the silo. There's about 2.5 feet there. That creates kind of a dead space inside the silo that gives more vertical climb and more space and more opportunity for gravity to affect on those fine particles. And that's really another contributing factor here. So not only do I have a very large diameter containment, to decrease the velocity of the exhaust airflow, and I also have the rotating wall column of air that separates the very coarse particles and the smaller medium-sized particles. I also have a very, very tall vertical climb. So I guess there's three contributing factors that make the dust silo very efficient at separating the very fine particulates out of the air. So when I showed the footage of my little probe camera inside of my silo in my previous video, I got some very important information from that footage. Although the resolution was really poor, the fact that I could see all the way down to the bottom of the dust pile while the machine was on indicated that there was very little dust in that center column of air inside the silo. And I could only see the bottom portion of the dust pile and a little vortex of dust that forms at the bottom. But in between that and the camera lens was pretty much clean air. I didn't have any particulates contacting the lens, and I could get fairly good visibility with that camera. As poor as it was, I could see straight down. And when I went and I opened up my silo, you could see that there was a lot of really fine dust that was in there. And some of it would fall in clumps and hit the ground and almost like dissipate, almost like turn into smoke instantly. That tells you that's really, really fine dust and plumes up like smoke. So that's an indicator that the dust silo has the capability of obtaining a lot of that really, really fine dust that would end up in the filter or even pass through the filter. The way my system is set up, the finest particles and the most harmful particles are just exhausted to the open air. So the dust that would create the biggest hazard for me in my space is the dust that I'm just blowing out. And I'm losing some heat doing that. But I'm also, dealing with a hazardous substance in a way that, in my opinion, makes the most sense. And the approach is just to get it out of the shop as fast as possible and, have it not be a problem ever. It costs me money, because sometimes I am heating the space and running my collector. It is blowing heated air out, so it is costing me some money. when I decided to put my containment outdoors, I pretty much signed up for heat loss, and there's no way around it. Because even when I was filtering inside, the air inside the silo was cold. So when I would run the system for the first few minutes, it would just be blowing that cold air from the silo inside. So it was like opening a door and leaving it open for a little while. So I was getting heat loss from filtering, and I didn't really see like the benefit, of saving, because sometimes I would be turning the system on and off all day just because I'm doing custom work, and that would just continuously, cycle in chilled air. When I first connected my system, I designed it to filter inside the shop. I didn't even have the exhaust part of the system as a concept yet, because I didn't know what that would do. So I started filtering in the shop, and that's how I intended to run my system. And the idea to exhaust it came after the fact, in the summertime, when it's so hot in here and I have to run exhaust fans to get airflow. I had the idea, it's like, well, hey, maybe I could just use the dust collection system as an exhaust fan to bring in fresh air into the heated shop. That's in the July and August temperatures can get very hot. What are you doing, kitty? You're looking photogenic today, aren't you? The dust silo is a very, very efficient separator, and I think it will perform better than most cyclones just because of its size and the fact that its size lends itself to being able to separate more of the finer particulates. Because the velocity in those really compact cyclones that people are making now for inside their space, the velocity inside those little cyclones is still very high. So you don't get that slow updraft, so the finer particles are still part of that exhaust. A large silo, or a very large cyclone, has the capability of separating much finer particulates out of the exhaust airflow because of its size. So because it's really big, it has a very slow updraft. And theoretically, if you could have an infinitely large cyclone or an infinitely large containment, it would function as a perfect filter, because the dust would have to travel an infinite distance and would have an infinite amount of time to get there. So, the exhaust end of that infinitely large containment would be 100% clean. You'd only get fresh air coming out the other side. Of course, you'd need to have some kind of wormhole in between that infinitely large containment so that you can recirculate your air back through the wormhole and perhaps make yourself look a little bit younger in the process. I don't know where I come up with this stuff. I'm trying to explain my system. Okay. I could go for some of those nacho cheese tortilla chips. I need to build more snack racks so I get more free chips. The guy gives me baskets of free chips every time, and that's how I get paid. It's actually a pretty good deal.